Hello everyone. In this topic, I will take first and second laws of motion, and I will start with the experiments performed by Galileo. Galileo was an Italian astronomer, and he performed a number of experiments to study the motion of bodies. And one of the experiment was experiments of inclined planes. So he took inclined plane and a ball was kept here, it comes down and then it moves up. It reaches up to this point. So whenever a ball was rolled from a certain height, it comes and then it rises to the other side of the inclined plane, and at the same height it stops. Now if this is changed, he kept on changing the angle of inclination of it, then this is still, it comes up to the same height, but now this distance covered is more. So if it has taken time t1 to reach here, then for this time t2, and t2 is more than t1, it takes more time now because it is covering more distance. If we further reduce it, still it reaches up to the same height, but time taken is further increased. So what he was doing, in an inclined plane, a ball rolling down on the inclined plane, then on the other side of the plane it rises, and then it stops at the same height. He kept on changing the value of this inclination of this inclined plane. He was reducing the angle of inclination. Still, in all these cases, the ball was covering the same height, whether it is this or the same height. But obviously now, if the height is same, this distance will have to be more, and same way this distance is more. So it is taking more and more time. What he concluded that, if we take the plane like this, then what do we expect? Certain time, more time, further time is increased. Now if it is made horizontal, this ball will stop when it reaches up to the same height. Here it will never reach up to the same height because it is now horizontal. If it is not reaching up to the same height, it means it should not stop. And this was the law of motion given by Galileo. He called it law of inertia. Means a body which is moving on horizontal plane and no force is acting onto it, it will continue to move indefinitely. Inertia means inbuilt tendency of all bodies to register change. All bodies have inertia. Inertia means every body wants to remain in its state. And when we are talking in this particular context, motion, then it means inertia of rest, inertia of motion, and inertia of direction. So a body at rest wants to remain at rest. A body moving with certain speed wants to continue with the same speed. And a body moving in any one particular direction wants to remain in motion in the same direction. So this is what we call as inertia. So inertia of rest, inertia of motion, inertia of direction. And the law of inertia says that a body at rest or in uniform motion will continue to remain in that state of rest or of uniform motion unless some external force is applied onto it. So body at rest or in uniform motion will continue to remain in that state of rest or of uniform motion unless some external force is applied. Now in this case, he was of the opinion that no force is acting, so it should continue to move indefinitely. It should never stop. Now, in day-to-day life observations, whenever we have a ball and we roll it on a horizontal floor, actually it stops. So actually what is missing here? It means whenever a ball is rolling and it stops after a certain time, it means some force is acting onto it which retards the motion of this ball, and that force is force of friction. So whenever a ball is rolling on the horizontal, it stops after some time because there is an external force opposing the motion of the ball. There is a frictional force by the surface. There is friction even when a body is moving in air. Frictional force offered by air. Frictional force offered by this solid. So these forces stops the ball. So these forces will stop the ball because these forces are acting opposite to the motion. If we can somehow make these forces zero, then a body moving with certain speed in some direction will continue to move indefinitely. So this is the law of inertia, also called the Newton's first law of motion. So Newton's first law of motion is a body at rest or in uniform motion will continue to remain in that state of rest or of uniform motion unless some external unbalanced force is applied onto it. If the forces are acting but they are balanced, then there won't be any acceleration. So actually this law is defining force. We are saying the state of rest will not change. The state of uniform motion means the speed will not change, the direction of motion will not change if there is no force. So force is something that changes the state of rest, the speed or the direction of motion of the object. This is how force can be defined. So law of inertia, or the first law of motion, includes, it defines force actually. Now we can take some example of law of inertia. I said there is inertia of rest, inertia of motion and inertia of direction. We'll take one example. Suppose we are sitting in a car and initially it is at rest and the car starts. All of a sudden we feel a force in backward direction. And what's the reason? Because our body wants to remain at rest. It was at rest. It wants to remain at rest. Now that part of the body which is in contact with the car, that starts suddenly in forward direction. But the upper part of the body, that still wants to remain at rest. So that's why we feel a backward force. Same way if the car is moving with certain speed and now all of a sudden the brakes are applied. Now this is inertia of motion. Our body is in motion. It wants to remain in motion. So when the brakes are applied, again that part of the body which is in contact with the bus stops. But the upper part of the body, it still wants to remain in motion. So that's why we feel a force in forward direction. And same way we can explain the inertia of direction when the car takes a turn. If a car is taking a turn, then again our body which is in contact, that will take the turn, but upper part of the body that wants to remain in the direction in which it is moving. So that's why we feel a force. So inertia of motion, inertia of direction and inertia of rest. You can go through a number of examples of the law of inertia. Now let's talk about Newton's second law of motion. And before we study it, I will define a quantity, momentum. Momentum of a body is, in a way, the amount of motion that a body has. It is the product of mass and velocity. So kilogram meter per second, that is the unit in SI system, and it will have same direction as of velocity. Mass into velocity. So it is defined only for the moving bodies. For a body at rest, the momentum is 0. Product of mass and velocity. Now, why do we need this concept? See, when we said that force is needed to set a body in motion and to stop a moving body. I'm giving you 2-3 examples. Just imagine that how much force do we need. Let us say an object, say a bicycle. Your friend is coming on a bicycle, it is moving towards you and you want to stop it. It's coming with a speed, say 5 kilometers per hour, and you want to stop it. You apply some force. If it is moving towards you, you need to apply some force to stop it. Okay. Now, if with same speed, 5 km per hour, suppose a truck is moving towards you or a car is moving towards you, can you stop it? Now see, both, I'm giving the same speed to both. A bicycle with the speed of 5 km per hour and then a truck with the speed of 5 km per hour. You need a very, very large force to stop a moving truck, even if it has the same speed. So it means it will depend on mass. It will depend on mass. How much, what is the mass of the body will determine how much force we need to apply to accelerate it or to retard its motion. Okay, now think other way. This time let's take same mass. A stone is thrown towards us or a ball is thrown towards us with a certain velocity. And now imagine if a bullet of same mass of the bullet is not too large, it may be equal to a small stone or a ball. If a bullet is fired on us, then you see again, now the mass is same, but it's impossible to stop a moving bullet because you need much larger force to stop it, though the mass is same. So it means to stop an object, you need larger force if the velocity is large. So it will also depend on velocity, and you are stopping it. Final velocity is 0 or it may not be. Even if you want to decrease, I am taking a general expression. We can write that initial velocity it has say v and finally you want to stop it. Or it has certain speed, say 5 km per hour, you want to make it 3 or 4. So it depends on how much is the change in speed that you want to bring, even if the mass is same. Now, again, third factor that will decide the amount of force that you are applying. Whenever you are playing a game of cricket, say, and you have to catch a ball. Now there are two situations. The ball is coming and you stop it like this. You take a catch like this. Another situation is you take the catch and move your hands backward. You are taking a catch like this and then you are moving your hands. When you are moving your hands backward, then you need to apply lesser force. it hurts less on your hands when you drag your hands backward, but you need to apply large force, or you are more likely to hurt when you have to stop ball like this without moving your hands backward. So it means larger is the time taken, lesser will be the force. So it depends on, we call it inversely proportional. More time, less force. Less time, more force. So force applied depends on the mass of the body, the change in speed, and inversely proportional to time. So here, that's why we said this is what? This is the change in momentum. So F is proportional to change in momentum upon the time taken to change this momentum. This is the time in which speed is changed from V to U. So, or this can be written as del P by del T, or we can write F is equal to M, or this we call constant of proportionality. Constant of proportionality, because whenever we remove this proportionality sign we have to, but we wanted to use as an expression. So in SI system we have chosen this constant as 1. So for SI system only I can write it 1, and this becomes change in momentum upon time. So we can define force as the rate of change of momentum, or some we can also write it del T. That is the same actually. I am taking T as the time in which the momentum changes by del P. So even if we write it del T or del T, doesn't matter. Just keep in mind that force is rate of change of momentum, del P upon T. Change in momentum upon the time in which the momentum is changed. It can also be written in different form. F is equal to M V minus U by T. What is it? M into rate of change of velocity. F is equal to ma. So net force is equal to mass times acceleration. Again, this law, second law also tells that if there is no force, there will not be any acceleration. So this is the net force, unbalanced force. If net force is 0, A will be 0. So this is second law, F is equal to mass times acceleration, or rate of change of momentum. Okay, from here, what is the unit of force? Unit of force is kilogram meter per second square, and this is also called Newton. So Newton is SI unit of force. So when we say 1 Newton, we actually mean 1 kilogram meter per second square. We can define a force of 1 Newton using this formula only, F is equal to ma. If m is 1 kilogram, A is 1 meter per second square, then F is 1 Newton. So we can say 1 Newton is that force which produces an acceleration of 1 meter per second square in a body of mass 1 kg. 1 Newton is that force which will produce an acceleration of 1 meter per second square in a body of mass 1 kg. So this second law, F is equal to ma, can be used to define unit of force. We can use it to find out the units of force, a relation between force and acceleration, mathematical relation. Now see again, if, see, acceleration is proportional to force. When we apply force, there will be an acceleration, but acceleration is F upon m. What does it mean? When we apply a force, I am applying a force, and say we have 3 bodies, 5 kg, 10 kg and 15 kg, and I am applying a force of 50 Newton. So acceleration will be different. Acceleration is force upon mass. So here it will be 50 upon 5, here it will be 50 upon 10, here it will be 50 upon 50. It is the least, this is the maximum. So it means if a force is applied on bodies of different masses, then the body with minimum mass gets maximum acceleration, and maximum mass minimum acceleration. And we said in the law of inertia that whenever we apply force, the bodies have inbuilt tendency to resist the change. So this law actually tells us that what is that property which determines the inertia. So a heavy body accelerates less, lighter body accelerates more when we apply a force. It means it is actually the mass of the body which determines inertia. So we can write that also. Mass is a measure of inertial properties of the body, or simple inertia. And when we are talking in this particular context, we are talking about inertia of motion. Otherwise, general meaning of inertia is also resistance to change. So F is equal to ma. Second law of Newton, F is equal to rate of change of momentum, the constant of proportionality taken 1 in SI system. First law of Newton is the law of inertia given by Galileo. He performed the experiments on inclined plane. That's all about the second law and the first law. Next class I will take Newton's third law of motion.